Isocrates theorem. So given a triangle, let's draw a triangle. So given a triangle and a line parallel to one side and intersecting the other two sides. So I'll draw a line straight across here. So this line right here is parallel to this side, and it's intersecting the other two sides. The other two sides, so the diagonals here, are separated into segments that are proportional in length. So if we label this A, or I'll use they're points, so I'll use capital letters. So capital A, B, C, D, and E. Then these diagonals are actually cut into proportional lengths, which means the ratio of CB to CD, so CB to CD will equal the ratio of BA to DE, which will also equal the ratio of CA to CE. Now, kind of a side note here. It says other proportions include CB to BA equals CD to DE. So notice that's not there, right? CB over BA isn't up here. Okay? But that's actually, this proportion is actually equivalent to the ratio of CB to CD equals BA to DE, okay, which is there. Okay? Notice why. When we cross multiply right here, we multiply DE times CB, so we'd have CB times DE equals, and we cross multiply here, we get BA times CD. All right. When we cross multiply this proportion, DE times CB equals cross multiply CD times BA. So these two things are exactly the same. Right? Which means these proportions are equivalent. In fact, anything on the same diagonal where we cross multiply, we can interchange them. So like we can switch the DE and the CA, and we would have the ratio of BA to CA equals the ratio of DE to CE. So BA to CA equals DE to CE. There's actually a whole lot of different ways to write these proportions that are all equivalent. And some of you have been catching on to that when you're doing proportion problems. You've been interchanging stuff and you get the same answer. And it's because as long as you are interchanging things on a common diagonal, like DE and CA, you're good to go. Okay. So let's find this length right here. So notice these two sides right here are parallel to each other. And they're on the triangle. So that means the diagonals are broken up into proportional lengths. So that means the ratio of 4 to 3, so notice I'm doing this length so this length to this length will equal the ratio of x to 5. So we cross multiply. We get 20 equals 3x. Divide both sides by 3, and we get x equals 20 over 3, which is about 6.6 repeated. Now there's another way we can do this, or what I said about interchanging. So we could also do the ratio of 4 to x equals the ratio of 3 to 5. So notice I did this over this equals this over this. So now when we cross multiply, notice what happens. First step, 5 times 4 gives us 20. X times 3 gives us 3x. Hey, that's the exact same as this. And so we're going to get the exact same answer. So there's actually, you can set up these proportions in at least 6 different ways. You know, it still works out. Okay, so the key is you want the diagonal, the same diagonal and the same ratio, basically. So 4 to x. So they either go in one fraction, 4 over x, or they're across from each other in the proportion, 4 equals x. Okay. So look at example 2. For another example, we'll do this again in 2 different ways. So we got parallel lines, okay, which means that the sides here are proportional. Okay? So one way we can set this up is the ratio of 4 to 5 equals, look at the other side. Okay, so we got 4 to 5 equals, now look what side goes with the 4 here, x plus 3. And then what's going to go with the 5? X plus 4. Okay. So we cross multiply. So we get 4 times x plus 4 equals 5 times x plus 3. And then you just got to watch out here with algebra that you distribute the number out here to both terms, not just one of them. I see this a lot where you write 4x plus 4, but it should be 4x plus 16 because we have 4 fours equals, and we distribute the 5s, we get 5x plus, and there's 5 3s, so that's 15. So subtract, I'm going to subtract 4x on both sides. Or this is bigger than this, so I want to keep my x positive. And then I'm going to subtract 15 on both sides. And so notice the 4x and the 4x subtract out. 16 minus 15 is 1. 5x minus 4x is x, and 15 minus 15 is 0. So 1 equals x, or x equals 1. Now remember, there's another way we could set this whole thing up. We did 4 to 5 equals x plus 3 to x plus 4. The other option would be 4 to x plus 3 equals 5 to x plus 4. So see how they go together? We could also do x plus 4 to 5 equals x plus 3 to 4. Okay, what's that? Right. It's not drawn to scale. Yeah. So we cross multiply, and notice what happens. We get 4 times x plus 4 equals 5 times x plus 3. Oh, look, that's the same as over here. And so then it'd be the exact same process. So you're not working in 2 different ways each time. It's just showing you that how you set it up, the proportions here just need, or the ratios need to be, again, common diagonals. That's the theme here. But there's at least 6 different ways to set up each of these proportions. Okay, at least 6 different ways. Maybe more that I haven't thought of. Okay. Now the converse of the triangle proportionality theorem would be if a line intersects 2 sides of a triangle so that the 2 sides are separated at corresponding segments of proportional length, then the lines must be parallel. In other words, the theorem said if they're parallel, then the sides are cut into proportional lengths. So the converse would be if it's cut into proportional lengths, then the lines must be parallel. So we can actually use this to show that these 2 lines are parallel. AB is parallel to EC, or that they're not. Okay? So we want to show EC, which is this segment here, is parallel to AB. So we need to show that these parts are proportional. So the ratio of 3 to 5 equals the ratio of 4 to 6. Okay. Now notice we could also check this by doing the ratio of 3 to 4 equals the ratio of what to what? So 3 to 4 equals 5 to 6. Right? Either way, we could check it, or we can do the reciprocals of these. So when we check these proportions, we can either just say, well, is 3/5 equal to 4/6? Or to check if they're proportional, we can also cross multiply. So 6 times 3 is 18, 5 times 4 is 20. Are those equal? So they're not equal. We can check this also. Notice 6 times 3 is 18, 4 times 5 is 20. Not equal, so it's just getting the same thing. So these lines are not parallel. So EC is not, oops, that's a really ugly knot. Try that again. Is not parallel to AB. If they had been equal, then we would say the lines are parallel. And the last example says, what must the value of x be so that DC is parallel to DE? In other words, we want to be able to do this. So we want to say, yep, they are parallel. So we have an unknown value right here for x. So in order for these to be parallel, these segments have to be proportional. Okay, so we set up one of our proportions here. So if I do 7 to 10 as my first ratio. Okay, so notice 7 is this short one right here, right? So across from 7, I want this short one. So we'd have 4, 2, and then 10 is the long one, so I want 10 as the long one, x plus 2. The alternative way to set it up might be the ratio of long to long, so I could do 10 to x plus 2 equals 7 to 4. Right? Now notice what happens when we cross multiply in either case. We're going to multiply 7 times x plus 2, 7 times x plus 2, 10 times 4, 10 times 4. So either way, the next line is going to be what comes out. So we cross multiply, we get 7 x plus 2 equals 10 times 4 gives us 40. So we get 7x plus 14, good, equals 40. Subtract 14 on both sides. So we get 7x equals 26. And so x would be, we divide both sides by 7. So x would be 26 over 7. Which is, if we want a decimal, remember you can press Control N on the calculator, it'd be 3 point something like that. But again, leaving the answers in fractions is actually preferable at this point. What's that? Yeah. Okay. So if you take a look at the assignment, the first page, it's saying find the missing element of each proportion. So look at the figure, and then look at the proportion that's given. It says the ratio of ST to TP. So find ST and find TP. Okay, so we have ST, TP. And then it says should equal the ratio of SR to something. So we have ST to TP equals SR to, and you basically just say, okay, what's across from TP? RQ. So for the first page, you're just filling in the missing segment in the proportion. So you can look at the segments that are given and figure out kind of what corresponds with the other side. Okay? And then the last 8 problems you're actually working out. So I'm going to go ahead and give you the answers for some of the last 8 problems. So whenever you get to them, you'll already know if you're doing them right or not. So look at number 9. I'm going to give you just the answer. The answer doesn't help you very much. All it is an indicator if you did it right or wrong. Okay? So number 9, you should get 10.5. So write that off to the left someplace there, just as a note to yourself of what the correct answer is. Number 10, you should get 1.5. Number 11, you should get 1.2. Number 12, you should get 29.4. I'm not going to give you the answers for 13 and 14. You'll see there's kind of yes or no answers, so I'll give those to you. But look at number 15. Number 15 is 7. And number 16, you should get 2. Now, on a side note, when you get to number 16, you'll see it says x slash 2 plus 3. All this is saying is x over 2 plus 3. Okay, that's what this is. So it's x divided by 2 plus 3. Or you could think of that as 1/2 x plus 3. That's all this is. These are 3 different ways of writing the exact same thing. You got the remainder of the period, so about 35 minutes to work on this.
Yeah, I got this.